Welcome to View Mastery's Proven Pinia Patterns course, where we'll explore the pro-level patterns you'll want to know when using View's state management library in production. We'll look at best practices for using Pinia in your apps and apply them to common scenarios. If you haven't learned the basics of Pinia yet, you'll first want to check out my other course here on View Mastery, Pinia Fundamentals. Compared to state management libraries of the past, Pinia is a tool that is lighter weight, more modular, less prescriptive, and enables more freedom. And as the saying goes, with great freedom comes great responsibility. The fact that we now have more options for how to conduct state management in our apps could ultimately lead to failure, where we have a project packed full of anti-patterns that we soon regret. Or it could lead to excellence, where we've elegantly architected our app to serve us for years to come. Throughout the course, we'll be covering the following topics: organizing our Pinia stores, options versus setup stores, accessing and updating state, and unique Pinia features such as patch, reset, and plugins. And to apply these concepts, we'll be using an example app. Let's take a look at that now. As you can see, it's a restaurant finder. Type in the city and search term to find restaurants within a certain area. The user can register an account so they can save their favorites, and they can read information pulled from the Google Maps API, such as ratings and reviews. This app tracks its global state for each logical concern within its own Pinia store, which we'll cover throughout this course. Now that we have a better idea of where we're headed, let's take a minute to talk about why we would even choose to use Pinia, when View 3's composition API has a powerful reactivity system with flexibility for sharing state. So if you've been wondering when exactly Pinia is necessary, I'll address that in the next lesson. See you there. Before we dive into Pinia patterns, let's get clear on why you'd want to use Pinia in the first place, especially considering that View 3's composition API already has a powerful built-in reactivity system with flexibility for sharing state. Just using the composition API, we can create a reactive object to serve as a store to manage global state. Then we just import that store into whichever component needs that state. Because of how View 3's reactivity system works, any component that imports this store can directly mutate its global state. And each component that depends on that state will update its view automatically when state changes occur. So when is a state management library like Pinia even necessary? It comes in handy when you want to have consistent patterns for collaborative organization. This is especially important for teams working on a large-scale application. An example of one of these patterns could be only using actions to mutate global state, versus mutating state haphazardly from just any component. If your app uses server-side rendering, you'll need to be careful with how you manage global state, since SSR apps initialize the application modules on the server, and then share state across every request. This could lead to security vulnerabilities. Pinia was designed to make it easier and safer to manage state in server-side rendered apps. Another reason you would use Pinia is to make use of the excellent dev tools, which provide transparency and feedback for debugging purposes. In addition to seeing the state of your app at any given time, it goes so much deeper than that. For example, we even have this timeline view where we see every mutation at the exact time it happens and in the order which it occurs. And with first-class TypeScript support, Pinia is ready to meet the needs of the modern developer. All of these reasons and more result in an overall smooth and intuitive developer experience, which is helpful as we architect our app's infrastructure. Now that we're clear about why we'd integrate Pinia into our projects, let's start to unpack its features in the next lesson. Just like with View 3 itself, when defining a Pinia store, you can use the options or the composition API with the setup function. While there's no right or wrong answer about which way is better, we can look at some of the ways they differ. First, let's review how to define a store with Pinia. Anytime we want to create a store, whether it's an option store or a setup store, we must import define store from Pinia. Then we pass a string for the name of the store as the first parameter, which must be unique since Pinia will use it to track state for each store, and it's what you'll see in the DevTools. Now let's take a look at the structure of an options store. Not coincidentally, this kind of store takes in an object as the second parameter of the define store function. The state, actions, and getters here are analogous to the data, methods, and computed properties of a component built with the options API. Alternatively, in a setup store, the second parameter passed into define store is a function. This kind of store will feel familiar to how you'd compose a component with a composition API. We create state with ref or reactive. Our action is simply a function, and our getter is a computed property. Note how we need to return everything in an object to make it accessible to other files and trackable by DevTools. Ultimately, the choice to use an options or a setup store comes down to you and your team's preferences and demands. Though it is worth pointing out that there are advantages of using a setup store. Since these stores allow us to take advantage of View 3's reactivity API, we can use composables like those from the ViewUse library, and we can also use watchers. We use both of these in our example app. Notice this behavior here, where if the user doesn't type anything into the city input, their current location will be found automatically. Looking at the code inside the geolocation store for this project, we can see this functionality relies on the useGeolocation composable from ViewUse to get the coordinates of our user. Meanwhile, the watcher is keeping an eye on those coordinates to trigger an action to fetch location data from the Google Maps API. Now that we understand the two different versions of stores we can create, in the next lesson we'll learn how Pinia helps us keep our applications more organized with modular stores. One of the most important features of Pinia is its modular stores. If you worked with Vuex, you might remember that we had one root store file and modules that broke off from that. Pinia, on the other hand, is modular by design. We create stores devoted to each major logical concern of our app, and then import those stores where they're needed. But it's not always straightforward to determine how to break up that logic into stores. So how do we go about organizing our stores? In other words, how do we handle store organization? Let's look at our example project to see a straightforward example and compare that against one that's a bit more nuanced. In our example project, a user can register an account, and the user interface will change depending on if a user is logged in, showing their name and their favorites in the navbar. To achieve this authentication behavior, we need to keep track of the user's state and of the actions related to that: register, log in, log out. So it looks like this could all be grouped into an authentication store. Like I said, super straightforward. But now let's look at some less obvious organization. Looking at the functionality of our restaurants app, there's a search bar with two inputs. The first input takes in a city location. The second input takes in a search term to find related restaurants. Both inputs have event listeners that trigger a function when the user types in text. Each function makes a call to the Google Maps API. City calls for the latitude and longitude of the location typed in by the user. Search takes in a term and calls for relevant restaurants within a certain proximity of the city. In other words, both the city and search inputs are utilizing location from the Google Maps API. So should they be combined within the same store? A Google Maps store, perhaps? Well, there are quite a few actions in this project that rely on the Google Maps API, so that's a lot of code in just one store. And more importantly, the actions aren't all related to the same logical concerns. To get clearer on how this should be storganized, we could break it down to focus more on: what is the Google Maps API being used for? What state do we need to track? When we ask those questions, we know that the first input is being used to make geolocation requests, while the second is dealing with restaurants that match the search term. Based on this reasoning, it sounds like we can make two stores with their own individual logical concerns: geolocation.js, restaurants.js. But wait a minute. In the restaurant store, when we request that list of relevant restaurants, it requires the use of geolocation data. This means we need to use data from the geolocation store in the restaurant store. You might be wondering if this ruins our approach to creating those separate stores. But no, it doesn't have to. This is what we call nested stores, where we can simply import the geolocation store into our restaurant store to access the bits of it that we need here. An important detail to remember about nested stores is that the way we share data, actions, and getters between stores will depend on the type of store, options versus setup. In a setup store, we can import and call the useStore function at the top of the setup function. Alternatively, in an option store, we'll need to import and call the useStore function within the action or getter where we are accessing that store. And with that, we've come to the end of the lesson. And the key takeaways are: group related data into their own stores by logical concern. We can also organize stores by features within our app. Do not assume a store should be created around one API or library. We can share state, actions, and getters via nested stores. In the next lesson, we'll learn about accessing our Pinia state. As I mentioned earlier in the course, other state management libraries tend to be more prescriptive, forcing developers to access and mutate state in a specific way. This can lead to unnecessary overhead, and in ways it feels limiting. One of the ways Pinia provides flexibility is by allowing developers to make their own choices about the patterns they use. So let's take a look at how we can access our Pinia state. If we are within a store itself, we have access to state properties in our actions and getters. But there are some things to keep in mind. as things are different within an options versus setup store. In an options store, within our actions, we access state using this. Within a getter in an options store, we must pass in the state to our getter to be able to access it. In a setup store, for both actions and getters, we access the state property directly, just as we would within the setup function in a component using script setup syntax. We don't use this. In this example, the state property is a ref, so it's written as city.value. And remember, we need to return anything we want accessible outside of the store. We can access a store's state from a component in a few ways. The most common way is to import the store into the view component and then invoke the useStore function. This lets us read and write to state using dot notation to access the state property on the store. However, using dot notation can become burdensome if we're using a lot of different state properties in a component. We can make our lives easier by destructuring state properties from the store so that we don't have to write the full store name for every state property. But we have to be careful how we do this. Our first instinct might be to do something like this. But this will break the reactivity. This might seem familiar, because in View 3 we can't destructure props unless we use a helper method called toRefs. And in Pinia, we can't destructure state properties unless we use a Pinia helper method called store toRefs. This will keep the reactivity intact. And this is how it would look to push new data onto that destructured state. Let's take a look at how vModel works with a Pinia store. We can use it to bind something like our input here to the Pinia state, so that our template stays in sync with the store and reacts accordingly. For example, in the geolocation store, there could be a watcher that will trigger a function when the city value changes. Let's take a look at DevTools and see how the state instantly reacts. As I type, the city value updates so the watcher triggers the getLatLong function, which updates the other state properties with address details. vModel allows us to access store state directly, and it also lets us mutate it. We'll be learning some other ways to mutate state in the next lesson. But for now, here's the key takeaways from this lesson. In an options store, we can use this. In an options store's getter, we pass in state. In a setup store, we access state properties directly. Do not use this. In a component, we can destructure state properties with store toRefs. We can use vModel to bind a value in our component to our store state. So far in this course, we've seen that accessing state is less prescriptive with Pinia, and so is mutating state. Let's look at some examples of that. The most common way to mutate state using Pinia is to trigger an action in the store that causes the state to be changed. In this example, clicking the Add to Favorites button triggers the Add to Favorites action in the Favorites store. Some people are surprised when they find out that triggering an action isn't the only way to change Pinia state. We can also change state directly by assigning a new value to the state property. In this example, we have a watcher on the city value. If the user deletes the city, we clear out those state properties directly so the user can start a new search. Another way we can update state is to use Pinia's patch method, which allows us to apply multiple changes at once to the store's state. Notice how we're passing in an object with the updated state properties inside it. Using patch comes with added benefits because it creates a single entry in the DevTools, and if we follow this convention throughout our app, we could easily do a search for patch to locate every place we're updating our state, or at least updating it in bulk like this. Something useful to note about patch is how it can take an object or a function as its parameter. For example, if our state property were an array, we could use array methods to update that state. Conveniently, Pinia also offers a reset method, so we can reset a store's entire state to its initial value. In this example, the reset method is used within the store itself to clear out the user state of our auth store. Note how we're in an options store. We could also use reset in a component like so. Using the reset function like this is really useful if we need to update an entire store at once, like when the user navigates to a certain page. Take a look at this example in the router file, where we use Pinia's reset method in the router itself. Here we're saying, whenever the user navigates back to the home page, clear out the previous search. Unfortunately, the reset method is not available with setup stores. This is one of the ways which option stores have an advantage. This is because the reset method relies on the state function to create a fresh state, replacing the current store.state with a new one. But we don't have access to that state function in a setup store. A workaround for this is to create your own reset method for an individual store, where we write an action that resets the entire store, like so. These are just some of the ways we can access and mutate state with Pinia. While it might seem like a lot, keep in mind that the DevTools support is excellent. We are able to see each state property and getter update in the Pinia DevTools panel, and we see which store they belong to. And we can see every action and patch occur if we check the timeline panel. When it comes to mutating our state, Pinia also offers a helpful method that we can use to get very detailed info about actions, the onAction method. As you can see, this method has a number of hooks we can use to perform some logic when a certain action happens. Note how we can pass in state as a second argument, in case we need it. Here, it's used to log information about which action has been triggered in the auth store. Watch how in the console we can see the name of the action, as well as the arguments that were passed into it. We've seen some examples of how we can mutate state. This brings us to the final lesson of our course, where we'll look at a way we can extend Pinia's API even further with plugins. We looked at a number of existing ways to use Pinia so far, but what if we need a way to extend Pinia's functionality beyond what it can do out of the box? For those cases, we can use a Pinia plugin to plug enhanced functionality into Pinia. We just write out functionality, like here where we are adding a property to the store. Then we tell Pinia to use the plugin by passing it to our Pinia instance in main.js. When we pass Pinia a plugin like this, Pinia adds extra information about our Pinia instance and our app that could be helpful to us through what is called the context. Pinia assigns the context object to our plugin, so we can access all the properties we might need when building more functionality onto Pinia, such as the app itself, the Pinia instance, the store the plugin is enhancing, or the options object passed to defined store. Ultimately, the plugins are simply functions. In this plugin, we're adding on a log context function that will log our context object so we can take a look at it in the console. Note how we're writing this plugin in its own file, with a plugins directory in our stores folder, then importing it into main.js. Then, to make use of it, we can call it like so in a store, like we're doing here, where we'll log the context object when someone authenticates into our app. When we log in, we see the context object is logged to the console. And over in DevTools, we can see the property and the method are available in the store in the Custom Properties section. Here are just some of the things we could do with plugins. Add new properties or options to stores, add new methods to stores or wrap existing methods, change or cancel actions, implement a side effect. Now let's take a look at how we can write a plugin that relies on the Pinia API, specifically the subscribe helper method. Subscribe is similar to views watch. We can use it to subscribe to, or watch for, mutations, so that when a particular mutation occurs, we can perform a side effect. In this example, we are subscribing to mutations in the auth store. We want to know if the owner of the website logs in. If they do, we'll trigger an alert to greet that owner. The subscribe method gives us access to the mutation by its store ID, so we can tell the plugin to just send an alert when the relevant action in the auth store occurs. While this alert feature is a bit contrived, we could extend this plugin to run a specific action only when an admin of the site logs in, like to fetch some protected data. Earlier in this course, we looked at onAction, which is also available to use when writing plugins to achieve special behavior, such as run code before an action runs, run code after an action has run, run code when an action fails, cancel an action. We could write a plugin that uses onAction to do something depending on if a user logs in, logs out, or registers. In this example, the onAction method watches all Pinia actions, and if one occurs in the auth store, it checks which action it is. Based on that action, it will send an alert. Here's that plugin functionality working live in the browser. Another cool use case for onAction is this elegant solution presented by Eduardo San Martin Morote, creator of Pinia. This plugin can be used to take errors that happen within actions and send them to an external service that you use, such as Sentry. This is super helpful to detect bugs during production. The last pattern we'll look at is an interesting one because it allows us to send data from a store directly to a plugin. We can add an option to a store, beyond the state, actions, and getters. If we create our own option in a Pinia store, we can add properties to that option for any data we want our plugin to be able to use. In the example, we've added the greeting option with an enabled property. We'll use this to send either true or false to the plugin. By doing this, we're essentially able to turn the plugin on or off. You might be thinking that adding an option to a setup store is not possible, but we can achieve this by adding the option as a third argument when writing the setup function for the store, like so. As you can imagine, this has a lot of potential to be useful when developing open source plugins for other Vue developers using Pinia. For example, let's look at the simple but effective public plugin called Pinia Plugin Persisted State. As it sounds, it's a Pinia plugin that enables us to persist our state despite a browser refresh. To make use of it, we'd install it in our project, then import it into main.js, and tell Pinia to use it. We then need to make sure to add the persist true option to the store we want to be persisted. Now let's check this out in the browser to see that it's working. If we hit refresh, we see that the user state is still there. So it did indeed persist. We've now come to the end of our course. I hope you feel prepared to put these patterns into practice in see that the user state is still there. So it did indeed persist. We've now come to the end of our course. I hope you feel prepared to put these patterns into practice in your own daily projects. To continue learning, I recommend checking out another Vue Mastery course, 5 Elegant Ways to Use Pinia, which is a more advanced course taught by the creator of Pinia himself, Eduardo San Martin Morote. Thanks for watching!